and in section 9.6 in general, yesterday and in section 9.6 in general, we're trying to count up how many possible ways, because we were leading into probability. That's coming into section, or coming in section 9.7. But probability, like Kyle said, 1 in 64 is the chances that you'll pick the winner of March Madness, etc., for your bracket. And we're not talking about like all the different, like having the winning bracket, but just picking the winner, technically, mathematically, 1 in 64, without going into any more detail. But in order to make that fraction, you need to know how many winning teams there are, just one, and then how many teams possible. Although you said it wasn't, no, it was 68, technically. Yeah. This section is saying, okay, well, to even figure out probability, to figure out how many successes or favorable outcomes of whatever it is you're trying to measure, and how many total outcomes possible, you have to know how to count up outcomes. So we talked about license plates yesterday. We talked about something like 2-letter words or 2 pairs of letters, but I said if they said words in homework, it's the same thing as like a pair of letters. 3-letter words, it just means like a grouping of 3 letters. I mean, there are some things that we can actually like count on our hands and be like, oh, we know that. But there are other things it's like, no, no, no. We don't want to write out 676 pairs of letters and count them up. Oh, that's a 26 by 26. We can kind of mathematically think about that. But then things start getting way beyond our ability to count up. So we have to have ways of dealing with it. And one way of dealing with it is the fundamental counting principle that says, if you're trying to count up how many ways, and thinking about that idea of not just a matrix, rows and columns if you're only measuring 2 things, but what if you're measuring 3 things or 4 things or 5 things, or with our license plate number yesterday, there were 6 things. A matrix doesn't work anymore because the matrix says, okay, this many options that way, this many options that way, put them all together. Now that we have 6 things, it's actually kind of more like a tree branching out in all these different options. A huge tree, 5,760,000, a huge tree. But all these 24 letters paired up with all of those 24 letters paired up, like branching out, paired up with all 10 possible numbers and all 10 and all 10. It's much easier just to do multiplication. So when you guys were trying to do this, there were different ways of thinking about it. One way is to say, okay, how many 3-digit numbers are there possible in the world? 0, 0, 0, all the way up to 999, right? 0, 0, 0, all the way up to 999. That's how many. So isn't that 999? That's 1 to 999 plus 1? 1,000. There are 1,000 3-digit numbers out there. How many of those 3-digit numbers would start with 0? 1 to 99 and 0, so 100. So one way of thinking about this is just thinking through, oh, hey, there are 1,000 different 3-digit numbers, and 100 of those start with 0 before the 1s and the 2s and the 3s, the 100s, 200s, 300s. So 1,000 minus 100, aren't there 900 numbers that don't start with 0? 100 through 999. But what's another way of thinking about it? You choose your first digit and your second digit and your third digit. You can have 0 through 9 there, 10 different options, 0 through 9 there, 10 different options, and 1 through 9 there, 9 different options. Oh, hey, it's 900. 2 ways of thinking about it, both ways work. Why is that helpful in letter B? The leading digit can't be 0, okay, so none of the 0 through 99, and no repetition of digits is allowed. Oh, okay. So 0 through 99, take those 100 away. I have 900 different options. And then take away 111, 222, 333, 444, 555, 666, 777, 888, 999. But it said no repetition at all. Which means 111 and 122 and 133 and 144 and 155. Oh, and 121, because that is a repetition of 1 and 1, and 131 and 141 and 151. Oh, and by the way, 122 and 132 and 140. Oh my goodness. Do we want to count those up? No. So what's a better way? How about our 3 blanks? How many options do we have for this very first number? Only 9. 0 through, no, 0 is not allowed. 1 through 9, right? But whatever digit was just chosen, whether it's a 0, oh, that's not allowed, a 1, a 2, a 3, a 4, a 5, a 6, 7, 8, 9. Whatever digit was just chosen, who was not allowed to be used again? That one. So there are 9 options for this one. There were 10 options for this one, except one just got used. So now there are 9. Because remember, 0 came back in, but 1 digit went out. And now 2 digits have been used, so how many options are now left? Isn't that a whole lot easier than trying to figure out all the different ones that don't belong or aren't allowed? Robbie. Oh, if we're talking about digits and talking about single digits that combine to be a 3-digit number, like for instance the number 500, 500. The number 5 could go in this place, the number 0 could go in that place, the number 0 could go in that place. But what I'm filling in is how many possible options there are. So this one, all the numbers 0 through 9 are legal. If you count up all those, 1 through 9 are 9 digits, 0 is 10 digits. There are 10 different options for filling in this one blank. Yeah, so we're talking about how many. So this is like who's allowed, and this is how many numbers those are. And this one was only the numbers 1 through 9 were allowed. So in this one, 1 through 9 are allowed, but this one, 0 through 9 are allowed, but take away 1. And then this one, 0 through 9 are allowed, but we've just used 2. Okay. Has anybody figured that out? We have 72 times 9, and 72 times 9 would be 8 and 6, 648? Okay. Or 81 times 8. Good call. That's easier. So what do you guys think for letter C? You tell me. 3 blanks? Okay. Adam just said 9. What do you think he's talking about? Okay. But then, Gavin, what else are you thinking about? Oh, because there's no restriction, huh? Because multiple of 5 ends in... Whoa! Woo! Look at them! Popping off! 980. Nice. It doesn't say anything about repetition. Okay. Yeah, to be a multiple of 5. This one, only numbers 1 through 9. This one doesn't say no repetition, so 0 through 10, all options. Sorry, not 10. Oh, that's 2 digits. 0 through 9. And then as Gavin said, to be a multiple of 5, it must end in 0 or end in 5 only. 2 options. Now guys, letter D. We could go making blanks, and I'll do that in a second, but couldn't we also use our logic? How many numbers are between 400 and 999? And some of us are like, oh, but wait, how many digits are below 400? Just subtract those from 1,000. Well, 1,000 is how many 3-digit numbers total? 0 to 399, isn't that 400 numbers? So isn't this 600? That's one way of looking at it, but the other way is, can't we do our blanks again? Couldn't that be all 10 and that be all 10, and this one can only be 4, 5, 6, 7, 8, and 9? Dun, 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 dun. Can logic and counting up sometimes work? Yeah, but sometimes there's no way. You got to use your fundamental counting principle. Does this kind of make sense? How to take a big situation, break it down into separate pieces? Multiplication is key because multiplication is basically figuring out how many branches there would be as you keep on adding on more and more and more and more options. So what about this? Ooh, do I have this one on the next page? Okay. What if we were to talk about, what's one of the first things you guys have to think about as far as getting ready for school in the morning? Okay. Obviously, we have many different priorities. At some point, you have to think about your outfit. Now, do you guys have uniforms so you only have so many options? As long as you legally wear a uniform every day. It's okay, you're not seniors yet. You still kind of care. Anyway, care when you're a senior too, and a junior, and everything in between. Anyway, so let's say how many outfits. I want to give you guys an idea, because I've been saying it, but I'm not totally sure you're tracking, as to what the multiplication is doing. Okay? How many outfits? That's the question. Let's say in your closet, as far as uniforms, let's not even go into sweatshirts. Let's just talk about like the basics, all right? Let's just go with how many shoes, right? Let's go with how many uniform bottoms, pants, shorts. I don't even want to go into like naming them all. And then how many uniform tops? Yeah, well, that's not really allowed. So anyway, coming back. Oh, there's uniform cargo shorts? Oh, wow. I didn't even know. Anyway, coming back. Coming back. And okay, if we want to, we can do sweatshirts too. Legal ones. My ones that don't have legal outerwear. We'll just say outerwear sweatshirts. Okay. Stop judging. Look back up here. If some of you guys are like, she never notices. Yeah, I never notice. It's not that I don't care. I just don't notice. Life's too short. I focus on other things. But those teachers that do notice, they are doing what they should be doing as far as integrity with the dress code. So please don't get mad at them. They're doing their job that someday you will be asked to do, and it won't make everyone happy. And if you don't do it well, you might not keep that job so long. Coming back. Shoes. I don't know. How many pairs of shoes do you guys have that you wear to school? Let's just say 2. Okay, bottoms. 2. Lots of laundry. Tops. Let's say 5. Let's at least hope you have 1 per day of the week. Let's at least hope. And you're like, Friday I can wear t-shirts. Anyway. Sweatshirts. Those are expensive. Okay, maybe we should like up the shoes. Some of you are like, I have way more than 2. All right, let's do 4. All right. All right. So what's going on? What do you guys choose first? Your shoes? Your polo?
Shorts.
Shorts? But interesting, not what I expected. Okay, so let's go ahead and say have, I don't know, shorts. Let's not use skirt just because that would definitely like ostracize half the class. So let's do shorts and pants. How about that? Okay, shorts and pants. So if those are your 2 options, then question, do you go ahead to go check on or pair up next? Shoes? Interesting. Okay, so shorts could go with shoes pair 1 or 2 or shoes pair 3 or shoes pair 4. Pants could go with shoes pair 1 or shoes pair 2 or shoes pair 3 or shoes pair 4. Now, once we have those, how many different outfits total right now then? 8, but we have a lot more to add. But that's assuming you already had this shirt picked out and you already had this sweatshirt picked out. We have 8 different options right now, just with uniform bottoms and with, hey, isn't 8 just 2 times 4?
Whoa.
Oh. Okay, now let's say we go ahead to the top. Okay? So as we go to the top, aren't we going to have 5 different tops?
40 different options.
I'm not even going to write the letters. So what do we have? We have 5 different options with that, and then 5 with that, and 5 with that, and 5 with... Don't we have 8 pairs of 5s? Oh, or 4 times 2 times 5. Oh. Now how many sweatshirts? How many of these little 2 pairs am I doing? Didn't we just have 40, so I'm doing 40 pairs of 2? Mathematically, could I have a computer program actually do this branching effect and actually get all the outfit possible combinations? Yeah. But mathematically, if I only care about how many, if I only care about how many, can't I just do 4 times 2 times 5 times 2? How many bottoms? How many shoes? How many possible tops and how many sweatshirts? Do you guys see the multiplication and why I'm talking about branching out? If we were to pair up every possible with every possible with every possible with every possible, it branches and branches and branches and branches, and we could have like a computer program get us all those possible different combinations. But if we're just caring about how many, why not just say 8 times 5 is 40 and 40 times 2 is, wow, no wonder you guys take so long to get ready in the morning. Just kidding, you don't really care, you just pick one, right? It's uniforms. Just wait until college and you have to wear real clothes. Anyway, so, boop. Uniforms are actually a blessing, believe it or not. You don't have to, yeah, just, whatever. Okay, here we go. And to some extent, everyone wears pretty much the same. Although you have the few that are rebels that are wearing the illegals. You that are like, well, I didn't do laundry, so I'm doing the best I can. Guys, hold on, we want to party, we got to focus. Permutation. You weren't even born. All right, permutation. Excuse me. Okay, that's true. Permutation. Ever permuted before? Okay, just kidding. I know. Permutation. It sounds kind of like mutation, right? Mutate? Don't worry, we're not mutating today. Permutation. But not. Permutation. An ordering of n different elements. Hey guys, what's n going to mean from here on out, at least for right now? How many elements? It has meant how many terms in the past, right? That one needs scissors. How many terms? How many elements? Ordering. What does ordering signify? The order matters? Oh. What does ordering signify? The order matters. Hey guys, if I'm talking about a combo pizza, does it matter if it was pepperoni sausage or sausage pepperoni? Doesn't matter the order, it matters what's on there, right? And what are pizzas called that like combine lots of different ingredients on one? Combination. Just throw it all on. As long as it gets on there, we're okay. Now, some of us are like, no, 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 this better not touch that. We'll just don't get a combo pizza. But anyway. Combo. Combo. Order doesn't matter. Permutation. Order does. So wait a minute. Where else is the word combo used where the order actually matters? Locker combination. But is the order important? So maybe it should be locker permutation. Maybe some of you guys should enact that change. Anyway, combo pizza, combination, order does not matter. Get it on there. Permutation, order matters. Like a locker combination. Okay, let's go beyond a locker combination. That's confusing. It has the word combination. How about a seating chart? Does order matter? If I was to switch Jaden and Tony right now, wouldn't that be a new seating chart? But it'd be mostly the same. It's still a new seating chart. It's a new arrangement. Arrangement. Are arrangements always where order is going to matter? Come on, my music people. Arrangement. What are musical arrangements? Like compositions, right? And doesn't it matter the arrangement of the notes? You guys listen to enough music. It matters the arrangement of the notes, right? It makes a difference. It makes a difference. What else does arrangement matter? Weren't we just talking about pairs of letters? Or oh my goodness, this is complicated. Pairs of letters, right? Pairs of letters. Is AE a different pair than EA? Yes, order matters. Order. So many Oreos. I'm just going to start stacking the Oreos. Is that okay? We're just going to start stacking. Just make room for the donuts. Well, not just these donuts, but also those donuts. I like the white powdery ones. Anyway. Oh dear. Not like that. Okay. So guys, does it make sense why the book is saying how many permutations of the letters? Order matters. One is first, one is second, one is third, one is fourth, etc., etc., etc. How many permutations? Guys, how many letters are we going to be using? 6, right? They don't tell us how many 3-letter permutations or how many 4-letter permutations out of 6. I guess we're using all 6. You picked up 6 letter tiles in Scrabble and you're putting them all down. How many different ways can you put them down on your little psh, psh? Okay. 1, 2, 3, 4, 5, 6. Could they ask for 3 or 4 or 5-letter groupings of more letters than you're going to be using? Yes. But if they're saying use all 6, kiddos, how many letters can be chosen for the first spot? But you just put 1 down, so then there's, and then there's, oh! Isn't it a factorial? Oh my goodness. 6 times, 5 times, 4 times, 3 times, 2 times 1. If you use n finite objects in rearrangements, it will always be, there will always be n factorial arrangements, but you have to use all n items. You have to use all n items. Why is there permutation? Order matters. Why is it a permutation? Order matters. So if you use all n objects, it'll be n factorial. But what if instead of not saying only use this many, what if they added and they said, okay, that was how many ways, how many arrangements for using all 6, but what if now they asked how many 3-letter arrangements? Let's say you picked up 6 tiles and for some reason you only had to keep 3 of them. That'd be a cool game of Scrabble. Anyway, you pick up more than you need, you get to put some back. Question. What would that be then? You pick 6, you only put down 3. You have 6 options, you have 5 options, you have 4 options, but how could we write that with factorials? It's not. It's missing 3 and 2 and 1.
You can do a fraction.
With 6 factorial over, where could 3 come from? 6 objects, only choosing. What does that look like? An NCR, but not quite. An NCR, but not quite. Guess what this is called? NPR, but not the National Public Broadcasting Radio. It is the other thing in your calculator. Out of 6 objects, you're choosing 3, and the order matters.
Whoa.
Now hold on. Why would NCR divide by yet another factorial? We learned NCR with the binomial theorem. It's n factorial over n minus r factorial, boom, 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 times r factorial. Why would there be fewer combinations than permutations? Permutation says ABC is different than CBA, and combination says no, it's not. Permutation adds it as an option. Combination takes it away as an option. Very similar formulas, but combinations say, as long as you have an A and a B and a C, even if you write it a B and an A and a C or a C and a B and an A, any way those 3 can be rearranged, 3 factorial, don't count as arrangements. Or don't count, I should say, as groupings. Combination says, given 3 items, however you rearrange it, we don't care. So combination says, no, no, no. We got to take away 3 factorial also. Permutations. If you use all n, this is a snazzy way of saying using all n objects. You have n, arranging all n. I know. I'll crack open the door just a little bit, even though it's kind of illegal. Yeah. They're the new safety policies that say we're not supposed to crack open doors. Well, it's a great call. Not technically supposed to agree with you, though. Shh. But as soon as you have n and you're only taking r, then we have our nifty formula that I just showed you. So that leads up to, I'm going quick just because we want to party. That's okay. I still have to go cut open the brownie bites anyway. Baseball. How many batting orders possible? Now, guys, hold on. Just like the brackets and how many different brackets possible and how many are actually going to be possible winners, I know there are extra considerations. I know that people who do this all the time are not just thinking about the math, but we are just thinking about the math, not the player abilities, the strengths, the weaknesses, the strategies to having different players go in different orders. We're just talking about how many ways, okay? A baseball coach is creating a 9-player batting order by selecting from a team of 15 players. Oh, is this an N using all N or an N using only R? N using only R. This isn't an N using all N. This is an N using only R. You guys okay at the St. Patty Day cookies that are the same or on top of each other? We're going to do that. Okay. Remember, if there's extras at the end of class and they're yours and you want to take them, put them in your locker for lunch, please do. Or if you want to put them back under the table and pick them up at the end of the day, please do. But if you're like, I don't care, leave them and we'll keep eating them. Hopefully not we. Hopefully them. Okay. How many? 9. 1, 2, 3, 4, 5, 6, 7, 8. 9. Whew! How many options for the first position in the batting order? 15, 14. This is so annoying. Isn't there a faster math way of going from 15 all the way down to Nice. How many will be left after you use all 9? 15 minus 9, 6 factorial. 6, 5, 4, 3, 2, 1 won't get used, so why not just mathematically take away 6, 5, 4, 3, 2, 1? Why not just do 15 PR? P9. And as Kyle already said, that is an operation in your calculator, math prob. Not the NCR, but the NPR. Guys, this one, if you take away 6, isn't it still 15, 14, 13? Okay, you're not going to do that in your head. Definitely a calculator. So either plugging in this formula or plugging in NPR. Wait, this begs the question on a maybe upcoming test that might be coming pretty soon. Next week, beginning of next week. As said test comes, do you think there's going to be a calculator portion? You need to know how to use your calculator and use the calculator tools. But do you think there also either might be a non-calculator section or certain blanks where I say, hey, you can use your calculator, but fill in the formula. And yes, you get or lose points by not being able to fill in the formula properly. Yes, the answer is yes. Okay. Boop, boop, boop. Repeated objects, the last thing of today. What if? Oh, you pick up 3 B's and 4 T's, 5 T's. You're going to stink at doing the Scrabble. But besides that, how many different ways of putting it down? Well, B, 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 and T, 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 T. Wait, but what if you rearrange the T's? Isn't it still the same arrangement? We're not talking about black and blue and yellow and red T's and them having different meanings. We're just talking about, no, how many arrangements? You guys remember what I said about the combinations? If 3 objects can be rearranged and not make a difference, don't combinations divide to get rid of that extra? We're going to do the same thing here. If we have 1, 2, 3, if we have 8 different letters, but if you just had the 3 B's, normally permutation would say switch the order and it's different. But guys, if you switch repeated letters, is it different? No. So given these 3 objects, 3 and 2 and 1, that rearrangement doesn't matter. We got to take away all those options. And then for the T's, 1, 2, 3, 4, 5, the T's, 5 factorial, those don't matter either. How does this formula work? This formula says your normal NPR, but divide by more, divide by repeats, but separate individual repeats. So if we try to rearrange the letters of algebra, Jason, stand, go. Don't even take your notebook, just stand, go. Hustle, 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 come on. Algebra, how many total letters? 7. But if I switch the order of how many, will it not make a difference? Oh, I only repeat 2 ways, right? But if you want to think about it technically, this would be the same thing as from 8 choosing all 8, and then 3 factorial, 5 factorial. From 8 choosing all 8. So if you were to say only do like 5 letters, you could do 8P5. But then you could still go ahead and divide by your repeats. Same thing here, you could do 7P7 divide by. We just need to divide by something extra because rearranging those 2 or those 3 or those 5 aren't going to make a difference. Does that kind of make sense? Kiddos, where are we right now?
Homework.
Section. I was going to say 6.1, but we're in 9.6.
Whoa. Wow.
We're in 9.6, and we have one more page of, oh, and that's it? Okay, at this point, I think we need to get some fun stuff at our desk, and then we'll finish off the last page in the last few minutes of class. Sound good? Combo pizzas. Didn't we talk about combo pizzas? Mushroom, sausage, sausage, mushroom. Doesn't matter. Mushroom. How did I get there? Oh. Pepperoni, sausage, sausage, pepperoni. Ugh. Just kidding, just kidding. To each his own. As long as we agree that pineapple belongs on pizza, we're fine. So, oh yeah. NCR. Didn't we already learn this formula? But guess what? It's also NPR. Just take away that extra R factorial. Because rearranging R objects in permutations makes a difference, but in combinations does not. But guys, we already know the formula from the binomial theorem. So what if we get something like this? A local college is forming a 6-member research committee having 1 admin, 3 faculty, and 2 students on the committee. But what are they choosing from? 12 faculty, 20 students, and 7 admin. Do they have to choose from a bigger pool to narrow it down for the committee? Yes. But once you get the committee in the room, does it matter what order they were chosen or what order they sit? Isn't it the same committee regardless of the order? So when we go saying we need 1 admin and 3 faculty and 2 students, can't we say, or even use, out of 7 admin, we're choosing, without order being important, 1, and out of 12 faculty, we're choosing, with order not being important, 3, and out of 20, we're choosing, without order being important, what am I choosing? 2? But what would be different if this was something to do with some sort of, I don't know, trivial, what am I trying to, seating arrangements of the committees? Order would be important. Instead of using C's, you would use P's. At the end of the day, we've learned how to count up how many, and we've learned how to count up how many when dealing with larger numbers of objects, choosing only so many. When order is important, which one's that? Permutation. And when order is not important, combination. What's due tomorrow? Guys, hang out, have fun, talk about the number pi. Is it a number? And how long it goes, but our party, sadly, is only going to last so long. So enjoy. If you guys want to take something for the road, feel free. If the next teacher wouldn't allow you to have food, please don't pack your plate full and then go walking into their class and getting me in trouble. That'd be so sad. There are only 2 more choco pies. There are just a few cinnamon rolls. But at this point, if you brought something and you're like, oh yeah, it's going to be left over, if you want to donate it to the day, that's totally fine. But if you want to come grab it and be like, nutrition, I'm going to make friends, feel free to come grab it as well. And if you're like, no, but I want it at the end of the day, you can come up and put it under the table back under period 2, and we will not touch it. So if you want to take something for friends, for locker, for future Pi Day parties, or future parties in general, you do not need to leave the food that you brought if it's not going to be eaten. Water, I'll let you leave at the bell to go get water on your way to class. If you were like period 6, you could have brought a case, but you guys didn't think it through. It's okay.